Okay, so this is a special video that I made for you for February 16th, and it's the 5.3 challenge problems. It's all the solutions. So I want to make sure that you understand them since I'm not here. And this way, if you have any questions, you can kind of go back and see what I've done differently and whatnot, and we can kind of go back over them if you do have more additional questions. So I'm going to start at number 1, go through 16, and show you exactly how to do them. So if there's one or two that you completely understood, you could fast forward a little bit, but I do want to make sure you're paying attention to the entire video this time. There's no skipping around. Alright, so number 1 looks like this, and your directions for numbers 1 and 2 are to write a rate that represents the situation. So this should really be your easiest, the easiest problems that you have, because you can pick any of these rates. These are all rates telling you that, so we have kilograms, and then we have cans. So our ratio would be our kilograms to cans. So basically, writing a rate that represents a situation, I could pick any of these. Let's say I pick this one right here. So what I would write for my answer is 15 kilograms in 6 cans. That's one example as an answer. You could have used the 5 and said 5 kilograms in 2 cans. You could have said 10 kilograms in 4 cans, 20 kilograms, 8 cans, and 25 kilograms in 10 cans. Any of those would have been an acceptable answer. This is just the one that I chose for my answer, but again, you could have a bunch of different answers. So number 2 looks like this. It's strokes and holes, and I'm assuming they're talking about golf here. So in other words, let's just focus on, let's do this one. So you're golfing and you have 40 strokes in 12 holes is what I'm representing. So you would just write it like this. 40 strokes in 12 holes. That's one example. You could have 10 strokes in 3 holes, 20 strokes in 6 holes, 30 strokes in 9 holes, 50 strokes, 15 holes, and 60 strokes in 18 holes. But again, this is the one I'm representing. You can use any of the ones I just said and you would still get it right. I would not accept if you said 0 strokes in 0 holes. Same thing with the last problem. It could not be 0 kilograms in 0 cans. For numbers 3 through 10, you had to write a unit rate for the situation that they gave you. This is where you would take a ratio table and you would, you take a ratio table and you would take what they give you and make it into a unit rate. And I'm going to show you how, starting with number 3. Okay, so I have $44 in 4 days. Now I want to make a unit rate for this. So I'm dealing with dollars and I'm dealing with days. And I want to go to 1 unit. So I'm going to make my ratio table. I know I have $44 in 4 days. What would I have if I could make this a 1? I know I want to make it a unit rate. So in order to make it a unit rate, I'm going to change this to a 1. How did I get there? Well, the only way to get there is to divide that by 4. Whatever you do to the top or to the bottom, you have to do the same to the top. 44 divided by 4 is 11. So my answer would be $11 per day, or $11 in a day would work as well. So this would be our answer. So for this one, I have 12 haircuts in 4 hours. So I know what my rate is from my haircuts to hours. It would be 12 to 4, which again is just a ratio. If I wanted to make that unit rates, how many haircuts could I do in just 1 hour? So I want to make that a 1. The only way to get there is 4 divided by 4 equals 1. So again, I do that up top. 12 divided by 4 equals 3. So my answer would end up being 3 haircuts per hour. Number 5 says 256 heartbeats in 4 minutes. So with this one, you can do the same thing. I've got heartbeats, we'll just say HB, and then we have minutes. And we know we have 256 every 4 minutes. How many heartbeats do we get per minute? Well, if I want to figure that out and I want to figure out my unit, 1 minute, I have to do the same thing I've done before. So I have 4 divided by 4 gives me 1 unit. I'm going to do the same thing up top, because with multiplication and division you have to do the same thing. So 256 divided by 4, okay, if you can't figure this one out, you have to do it over on the edge. Okay, don't forget how to do the simple math like this. 4 goes into 25. 6 times, notice where I wrote the 6. I didn't write it over the 2, I wrote it over the 5. Okay, 4 times 6 is 24. Subtract it, bring down my 6. 4 goes into 16 4 times. 4 times 4 is 16. I have 0 left over. This is a really important concept, you guys, because a lot of you this is where I'm finding mistakes. Take your time, make sure you're doing it correctly. So 256 divided by 4 ends up equaling 64. So my answer would be 64 heartbeats per minute. Number 6 is 15 liters in 3 minutes. And again, doing the same thing. We've got our liters to minutes. Lots of texting happening, sorry. Alright, liters to minutes, and I have 15 to 3. And I want to make that a unit. Oh boy, my little lines are all over the place. Alright, so I want to know how many liters per minute, basically, if I'm finding a unit. So I'm going to divide that one by 3. And I'm going to divide that by 3, because the only way to get down to 1 is to divide out the number by itself. Do the same thing up top. I should come up with 5. So my answer for this one would be 5 liters per minute. Or you can write it like this, 5 liters per minute, or per 1 minute. No, that wouldn't be like 5 liters of Mountain Dew in 1 whole minute, because that would be, you'd get sick. So don't try that either, okay? Don't do it. For this unit rate, I have 12 cans for 6 people. I want to know how many it would be for 1 person. So I'll start with cans, and then people. I've got 12 cans, 6 people. To get to my unit, I would have to get to 1, divide that out by 6, do the same thing up top. That means I would have 2 cans per person. Number 8, you have 27 outs in 9 innings. So I have outs in innings. And I have 27 to 9 is my ratio. What would my unit rate be? So I have 1 inning. So every inning I would have 27 divided by 9 gives me 3. So obviously we have 3 outs per inning. And you baseball people out there would probably not even have to do any math for that one, because we should all know that if you play or enjoy baseball. Number 9, you have 85 drops in 5 minutes. I have no idea what that means. We could be referring to all kinds of things in this situation, but maybe you're throwing footballs and you drop it 85 times in 5 minutes. That doesn't make sense either, because that's a lot of throws. Wow, I give up. I don't know what this one is. So, all right, so we have drops and we have minutes. You could be talking about like eye drops. No, that'd be weird too. You wouldn't put that many eye drops in your eyes. All right, so let's just go with what we know here, because we don't know what they're talking about. If you come up with a really good solution to what your drops per minute are, I might just be really excited about giving you a ticket for coming up with a really cool idea between drops per minute here. Obviously, we want to get to 1. To do so, we divide by 5. We're going to do the same thing up here. And so the answer would be 17, because 17 times 5 equals 85. So your answer would be 17 drops per minute. Don't say eye drops, because you should not be putting 17 drops of anything in your eyes per minute. Alright, this just gets better and better. So now we have 36 children from 12 families. So now we're figuring out... Whoop, well, I'm going to erase that. That's going to bother me if I don't. Children and families. We've got 36 of them. There's 12 families. We want to get down to how many per family. So obviously you're going to divide by 12 and do the same thing up here. You're going to divide by 12 and you should come up with 3. Because 12 times 3 does equal 36. So we have 3 children per family. So there's a couple different ways you could have done number 11 and 12. You have to decide whether the rates are equivalent. So you could have done a ratio table here. I'd be okay if you set them up as fractions and tried to figure that out. But the first one, we've got 17 heartbeats in 15 seconds and 68 heartbeats in 60 seconds. Is that an equivalent rate? So we have to figure that out. Okay, so I set up a ratio table to figure out what I was going to come up with. And my first thought is, okay, so what can I use to go from 15 to 60? Because that's what I can go from. Well, you have to really think about that. I mean, could you go right up to 60 to something times 15 equals 60? And that's the number one place that you start off when you're talking about equivalent rates. So with enough thinking, you should say to yourself, okay, 15 times 4 does equal 60. But here's the kicker. Does 17 times 4, does it equal 68? And that's what you have to figure out. So you have to do out your work. Make sure 4, 5, 6. So yes. So my equivalent rate would be times 4 on the top. So my answer to this one would be yes. They are equivalent rates. Alright, so this one I've got 96 miles on 4 gallons and 380 miles on 15 gallons. I've got to compare them. Are the equivalent? So you could start off with miles and then gallons. And we've got 96 to every 4. So that's where I'm starting. And again, you have to ask yourself, can I go from 4 to 15? Well, you can't get there right away because it's not a multiple or a factor of 15, but we could try to make our way there. My first thought doing this one would be to try to get, because we're going to 15, so my first thought would say, alright, I know that if I get to 12, then I can get down to 3, which can get me to 15. So I'm going to take 4 and I'm going to times it by 3 to get to 12. And do the same thing with my 96, which will get me to 288. So there's my next equivalent rate. Then I've got to get to a number that's going to make it so I can get to 15 eventually. Extend these lines out here. So my next one, I want to divide out my 4 so I can get to 3. If I divide 4, oops, on top. Again, I'm just quickly going through this, but if you did your math, it should be 72. Then I want to multiply by 5 to get to my 15. Now this is my end product. This is where I'm going to stop. So if this number here equals 380, then yes, it will work out. What I did down here was I multiplied it by 5. So I got to do that up here, multiply by 5. 72 times 5 ends up being 360. So, is 380 miles on 15 gallons an equivalent rate to 96 miles on 4 gallons? No, it's not. It would not work out because you do not get to 360 if you have, or 380 if you have 15 gallons. You get to 360. So it takes a little bit of time. There's other ways that you can obviously do it too, but this is the route that I took. So you just need to make sure that no, it does not work. You could also look at it as a fraction if you wanted. So number 13 was a little more tricky. It's a word problem, and you're dealing with two different units of rate. So that's what you have to be really careful of. I'm going to point those out right now. So you received 9 text messages in 12 minutes. What is the rate of the text messages per hour? So I go from minutes to hours, so you all have to understand and know that obviously there are 60 minutes in an hour. So going from there, that's how you can figure this one out. So we're going to start with our texts. And we have minutes. And our text right now, the ratio they give us, or the rate they give us, is 12 text messages, or 9 text messages in 12 minutes. Okay, so we want to know what is the rate of text messages per hour. So I know that I have to get my next number up to 60. Well, we should all be able to say to ourselves, well, what times 12 is 60, or 60 divided by what equals 60? Okay, I've been thrown off really a lot by all my text messages. Sorry. Okay, so back here. So we should all know that 12 times 5 gets us to 60. So if we get to 60 here, we can multiply 9 times 5 and get to 45. So my answer should be 45 text messages per hour. And that's my answer. For number 14, this one says you studied for 14 hours last week. What was your unit rate of hours of study per day? So if we set up a ratio table, I've got hours and I've got days. We have 14 hours for our 7 days. And the reason I got those numbers, let me just write my chart here. The reason I got those numbers is because if you look up here, you studied for 14 hours last week. Well, we have to recognize that when we're talking about week, we're talking about 7 days. Okay, 7 days in a week. That's where I got my 7 over here from. A lot of the times on tests and quizzes that you take for this chapter, you're going to see stuff like that you have to really think, okay, what does that actually mean? So what was your unit rate of hours of study per day? So now I can get my unit rate per day because I can say 7 divided by 7 gives me 1, and 14 divided by 7 gives me 2. So my answer would be 2 hours of study per day. And that's your total answer. For number 15, you might have done a little bit of research on this one. The question says, in a walk for charity, you walk at a rate of 1,000 meters per minute. How long does it take you to walk 2 kilometers? Well, now we're dealing with kilometers and meters. So you had to do some research and figure out how many meters are in a kilometer. So I'll just let you know there's 1 kilometer equals 1,000 meters. So that's kind of prior knowledge that you had to have. I'm going to start though, and I'm just going to do this in meters, and then we'll convert it later. So if I've got my meters, that's what I'm working with on my ratio table, and I've got minutes that we're talking about, and I know right now that I can do 100 meters per minute. What the question is asking me to get to is how long does it take you to walk 2 kilometers? So if I know that there's 1,000 meters in 1 kilometer, I'm going to get this number to 1,000 to see how many minutes it takes me to walk 1,000. And in order to do that, you have to multiply to get to your 1,000. You're going to do the same thing down there. So I'm going to multiply them both by 10, because 100 times 10 is 1,000, and 1 times 10 is 10. So in 10 minutes, I walk 1,000 meters. With that said, that means I walked 1 kilometer, because 1,000 meters, which is what I have right here. I'm change my color pen so I can kind of point that out. So if I've got 1,000 meters equals 1 kilometer, I can say this is also 1 kilometer. The question says, how long does it take you to walk 2 kilometers? So if I know in 1 minute it takes me 100, I can walk 100 meters, and I know in 10 minutes I can walk 1,000 meters, which equals 1 kilometer. Whoops, where'd my pen go? Okay, so walking 1 kilometer takes me 10 minutes. How much time does it take me to walk 2 kilometers? Well, basically all you're doing is just doubling the amount you have here. So that means it would take me 20 minutes to walk 2 kilometers. So my answer would be 20 minutes. Basically, I knew that it took me 10 minutes to walk 1 kilometer, so it would take me 20 minutes to walk 2 kilometers. Alright, so last one, number 16. It says a deli sells a sandwich spread for $6.40 per pound. How much do you have to pay for 24 ounces of the spread? So you had to do a little bit of research, and you had to understand and realize that there are 16 ounces in 1 pound. So I'm going to take a little different route than I did in the last one. The last one seemed to be a little bit easier to do. This one you want to do, you have to realize a couple things. So if I have the money up here of how much it costs per pound, and I'm going to put my pound down at the bottom. So I've got $6.40 per 1 pound. Okay, well, this is what we know information-wise is true. If I were to do the same thing, knowing that my 1 pound is now 16 ounces, so I'm going to do my money, and now I'm going to do ounces. And I know that it's $6.40 for every 16 ounces. And that's true because I know that 1 pound equals 16 ounces. So now I can just simply make sure that I can get my 16 to get to 24, because that's what we're talking about. We need to get to 24 ounces. And the easiest way to do that is to continue my table. I'm going to take 16, I'm going to divide it by 2, because I know if I divide it by 2, that will get me to 8. And I can easily get from 8 to 24 by multiplying it by 3. Okay, so we just got to do the math up at the top. If I divide $6.40, well, that one's pretty easy. You could probably do that one in your head. You have $3.20. Then I'm going to multiply it by 3, because that's what I did down here. $3.20 times 3 gives me $9.60. Now, my answer ends up being, it's going to cost me $9.60 for 24 ounces. And that's your final answer. Now, I could have done this on the number 15 as well, but like I said, we were dealing with something a little simpler. I mean, this we had the 16 involved, so that's why I didn't want to do 2 different ratio tables like this. But this is how you have to set it up. You might have to do a little research. Obviously, in a test or a quiz, I'm not going to give you a problem that gives you ounces to pounds unless I give you a conversion chart. But in this situation, I do expect you to do the work and look it up. So those are all of the answers and how to work them out, numbers 1 through 16. If you have any questions or you want to go back and review them, this is the time to do so. And please let me know if you have questions tomorrow. I can answer them for you then.